Okay, welcome to our session on MPContribs. We're about to start. I would ask you to go to nextgen.materialsproject.org. Make sure you're logged in and you can load the page. My name is Patrick Huck. I'm a computer systems engineer in Materials Project. My background is in high energy physics, and I've developed the MPContribs platform over the last few years to enable Materials Project users to contribute their data to Materials Project and expose it to our now 200,000 users. To start, let's start exploring materials on nextgen.materialsproject.org. Cody a couple of days ago has introduced the website and what it does. So I think most of you should be familiar. If you click on Explore Materials, I would go to one of my favorites that I always check is Cobalt Arsenide, because I know there are contributions in it. And so we'll enter COAS2. The one that I want to look at is MP2715. If we click on that, we're on the detail page for that material. And there's an entry on the left that says contributed data. Every material detail page will have that entry. And if there is contributed data in for that material available, we'll show it there. So if you click on contributed data, you'll see a little abstract of where the MPContribs platform is and how you can apply and share your own data. But for now, in this project, we have 4 contributions, some on band gaps, on electronic transport properties, and also topological material and open catalysts. If you click on see more, you'll see some overview in this card about this contribution, namely where the details are, what data is in there. You can see by hovering over it, these don't have description. But for instance, on the electronic transport properties, there's actually descriptions of what numbers are in there, what they mean, and you can also download potential tables in these contributions. There's a description, the authors, references with references to direct open access PDFs. Once you click on like any of the projects and their header, it'll take you to the according landing page on MPContribs. This is what this looks like. It's basically an overview of the data in this project. Again, it repeats the authors, your contact for who's responsible for that data set, the references, more on the description with the information, some other info that explains the columns in this project, and then an overview over all the contributions and the data in it. So carrier transport, you can see, is a pretty big one, has 47, almost 48,000 contributions in it. One contribution is what I consider assigned to a material on Materials Project. That's just what we've looked at. And I can scroll through this and scroll through the right here if I want to, and actually see tables that I can download. Tables in the MPContribs sense are basically CSV files, 2-dimensional data that if I click on one of these, I can actually see a preview here, what that is, what the title is, the x-axis, units, what the columns are in there. And I can also directly download it on that black arrow. I could go and filter it a little, say, I want to know the ones that are metal and filter this. So this gives me 17 to 270. Sorry, a little bit scrolling here. It's a lot. It's 49 columns in here, and I could basically also use this to reduce it to the things that I may be interested. The metal column, maybe a few of the values here, and I could download that as JSON or CSV. And you can see here that on these landing pages, it actually through an identifier that is the material project, it takes you back to a contribution, or it takes you back to the Materials Project detail page and links it that way, links it back from both sides, from MPContribs and from Materials Project. We can also look at the detail page for one of these contributions. This is now for MP19171 in the carrier transport data set. It shows you some example code of how to actually get to this data, what the numbers are. See, this is kind of hierarchical, simple key value data with where we just point to numbers, and then there could also be structures in there, PyMargin structures. It could be tables that I talked about, and tables automatically get rendered as graphs internally, where you have some control over what the title is and the x-axis and so on. But we'll go through this, and the goal of this lesson is to show you how to basically get to a point where data shows up on MPContribs. Another way to get here is basically to directly go to mpcontribs.org, if you want. We have multiple versions of this running that serve different purposes. The one that I've just shown you is the main one, contribs.materialsproject.org, where we have all the data sets that really don't fall under the purview of the others. We have one version of this running that is responsible or carries machine learning data sets, ml.materialsproject.org. You could click on that. So that's where Alex has added a lot of material benchmark data sets where he has, I think he's talking about it later today, so I won't go into the details here. If we go back, we also have on light sources, and the one that we're going to use today is called workshop-contribs.materialsproject.org. So let's look at that. This one is empty, and the idea here is that we're going to spend the next 45 minutes to fill some data in here. Basically, what I would ask you to do now is to click on the contribute button, which will bring up a form. And what you'll do here is basically ask us on the materials project side to create a project for you that we'll approve. So we'll enter some information here, and everyone basically can follow along and just adjust it to their own project. That this will be your project on MPContribs that you'll use to upload some data in a bit. So let's use our own names here. First initial, last name. A project name in this field is something that is URL safe, so it should only be alphanumeric with an underscore. Let's do something that is WS, short for workshop, and use our first name and last name initial. For short title, let's just do, and you don't have to include your name here. I'm just doing this for the workshop to kind of distinguish our projects from each other. So let's do as a short title something like this. So it's my name and then refraction index. Refraction index is the data that we're going to use to upload, and we could also put a longer title in here. This. Yeah, wherever I'm using my name, feel free to use your own, so we can distinguish the projects. The most important part is that this is different and kind of unique to you. This is just the description. So we would index, data. Project. It really doesn't matter as much. The information you put in here is important for us on our side when you apply in the future to know a little bit about the project. For now, we have people waiting for these applications, and they'll approve them. So you don't have to go into details in the description. And I just want to, as a reference, I want to put in the website, which is HTTPS. Refractive Index. So if you hit apply, should basically get this message. I hope all of you do that. Thanks you for your submission. In the background, there will be an email going to us and our admins, and I think Jason and Matt agreed to basically approve anything that comes in. So this will take a little time. In the meantime, we'll go back to CoCalc and start looking at our data. So once you're in CoCalc, again, go to workshop, lessons, and then 07 MPContribs. And we're gonna just start a new notebook here. Okay, to get us started here, just two minor things. One is we want to set the project name that we just chose. So in the application and the form that you just submitted, let's just save this here so we don't get any errors in the future. And we also want to save our API key. I think Jason and Cody have shown you in the past of how to get to your API key, but I'm just going to do it again. If you go back to the NextGen site and scroll up to your dashboard, there's going to be that API key on the left. Copy that and paste it back here. We'll use that for both the MP raster that we're going to use to talk to materials project core data and to also talk to the API of MPContribs and its client. I'll give you a minute to catch up here. Okay, to continue, we will need a few imports first. So we'll use the MPContribs client, which is a Python client for the MPContribs API. So that'll be from mpcontribs.client import client. We also need our MP raster for the core data. So that would be mp_api.proj import MP raster. We'll need data frames from pandas. So from pandas import data frame. And we'll also need access to our refractive index data. There is a library called Refractive SQLite. Without going into too many details here, it's a library that basically has all the refractive index data that's on refractiveindex.info. I'll invite you to check out that website. It basically just has wavelength dependent refractive index data that we can use as an example to contribute to materials project. So from Refractive SQLite, import operations SDB. Okay. So in the meantime, I think Jason and Matt are probably still going to approve projects, but we're not quite talking yet to MPContribs. We'll just start exploring the refractive index data and get some data that we can put up on MPContribs into our projects. We'll get access to the database. So that would be db.database. So capital D. that's preloaded. The refractive DB file is preloaded in your environment, so this should load pretty quick. And we could run a search on that DB. Let's say, let's look for gold, and I want an exact match to gold. That should give you something like this. Yeah, what we see here is basically a list of gold refractive index overview. The data that's in here is basically where does it come from? This Johnson page, whether it has refractive or has extinction data, and then the wavelength range that this data exists in and how many points they've done. I think there's a total of 2,700 of these rows in there. I will be working with gold, but after the lesson or as an exercise, you can definitely choose different elements or different formulas here. First thing I want to do, though, is I want to make sure that the data that I'm uploading has refractive index data and has extinction data. So we'll load some data from that way. Basically, the materials that we now want from the database is search. And again, this is all refractive index library code. I'm not going to too many details of how that works. It only serves the purpose of getting us data that we can contribute to a materials project. This would be, in your own example, other code that you have available that would prepare this data. So let's search here for everything that all the pages in that data set where the book, which is the formula in this data set, is gold and has refractive is 1 and has extinction. So this should give you 23 results, or if you have chosen a different formula and provided it to the book variable here, you might get a different number of results, but that's basically now the data that we need to put into MPContribs, and we want to next prepare one contribution that we can put up on our project. Just as an overview first, where we're headed. In the end, a contribution to a materials project to one MPID would look as a dictionary, like something like a project that we want to assign this to. You don't have to type this yet. This is just an example. The project is our name that we want to assign this contribution to. There is an identifier key in it that links it to the MPID. So this is something that we'll need to figure out. We'll need an MPID to link that data that we just loaded to. We'll also want to add some data, as is one of the components in a contribution is just a hierarchical key value data. So that could be something like later, I'm sorry, shouldn't have executed this. Something like, I don't know, a value A that is 3 electron volt, or it could be nested into, say, okay, I have a string here that says hello and a number that says 3. So you can see that this is basically a dictionary that lets you add a certain amount of organized data. It's free form, but there's restrictions on the keys, and you would generally put in values with units, and MPContribs would know how to parse them and check them. The other three components in a contribution are structures. These are basically a list of Pymagen structures. We've talked about them in the lesson in this workshop. Then there's tables that we've seen in a carrier transport data set. Those are pandas data frames. So that's what we're going to use in this lesson. And this is, please don't execute this cell. This is just pseudocode to kind of give you an overview of what a contribution would look like. And there can also be attachments. So attachments would be basically just a path to a file that you want to add, or there's its own MPContribs client attachment class that you could use to initialize an attachment. The idea here is the same as with emails, that anything that doesn't need to be queried, where you think like, oh, I don't think the user needs to see this as a table. He doesn't need to query on that data per se, but I need it in there and I would want to like download that attachment. I could basically just get it. But the same way you would search your emails, you can't really search through attachments in most cases. You can look for structures and tables, and you can query the data in terms of ranges and values, and if it's equal and contains and so on, but that doesn't work for attachments. It's a way to save some extra information that you either don't want in data or that wouldn't fit into that pattern. So, okay, so I'm just gonna put this in backticks and make it a markdown cell. So this was just an example to show you where we headed. We kind of want to get to the data that from the data that we loaded to something like this. So we won't do structures and attachments. We'll just add the tables. We'll get a data frame, and we'll add some data values into this. So let's go back and take a look at our materials that we've loaded. Say a look at the first one here. Basically just one of these rows with the information that we've seen before. And what I need here is this 58, the ID, to get some more information. So I'm going to save this as page ID. And I'm going to ask the database to give me that material. So what we want to do now is, from this mat variable, from this material, we want to kind of find our way to a contribution and see how this maps to each other. Another thing we'll need for that is our rester to MP data. So we'll initialize this with MP rester and the API key. Jason has talked about this yesterday. And then we'll try to get some data out of materials. So the first thing I can look at is, you could type mat and then hit tab to autocomplete and see what mat provides. And you can see that there is get refractive index in there, there's get extinction coefficient, there's the complete extinction and refractive table. So those are the things that we're going to use to make a data frame and get some tabular data. And then there's page info and the points, range max, range min, and so on that we've seen before. So for now, let's look at the page info and see that the page info basically just reflects that row again that we had before. And what we're specifically interested in is that book variable, because that gives us the formula. So we're assigned the formula to mat page info book, and we'll use that to get an MP ID from materials project. So if you remember, you could use MPR get materials IDs for it. That's from the MP rester, a function that basically looks things up by formula. And that'll give us a list of 3 here. The one that I'm looking for is the first one. And the reason I'm doing this is basically I'm selecting an MP ID that I want to assign this material data to. Set this as gold, and I feel fine with MP81. And I'm going to map this into a string because I just want the MP string and save this as MP ID. So we've got our identifier. This basically covers this part up here. We've got an identifier and the MP ID. Now we're looking at data and see what we can find out of this materials data. Again, you remember there was range min and range max, which is the range of wavelengths that's covered in that spectrum. And we want to save them as separate variables here, and as our min and our max. And they're given in micrometers, and we want them as nanometers. So we'll just multiply this by 1000. The same with our max. The reason I've done this is basically to use the function of get refractive index. You can look at the help here. Scroll up. So I'm looking at the help of mat get refractive index. We need a wavelength, and the wavelength is in nanometer here. So we'll just as a representative refractive index, we'll just use the midpoint between these two ranges. I just call this mid, and we'll call it R min plus R max, and divide that by 2. So that's just a representative midpoint here. We could calculate. That gives us a refractive index at that wavelength, and that's a number that we'll save as n. So as a refractive index. And we can do the same for the extinction coefficients, which we'll call k. Get extinction coefficients. I'm hitting tab again to autocomplete and calculate that at the same point. So this will give us a few numbers that are interesting for this data set that we want to put up on MPContribs. So these values are min, are max, MID, K, and N will add into data. And the last piece that we want is a data frame for the tables. So let's see what we can find in this materials data set. I first want to save the x-axis because I'm going to need that in a few times now. I want to save that in a variable. So the x-axis of the data frames and the tables that we're going to add is the wavelength. Give it a lambda, a symbol. What I did here was / lambda and then tab that will convert this lambda into a actual character. And the same I'm going to do for the unit, which is micrometers here, and save that in a variable x. And I'm going to take a look at the material again. We remember it had this get complete refractive function that we can look at the help again here. And it basically just gives us the complete refractive index information as a list of lists, namely the wavelengths as an x-axis and then the refractive index as a y-axis. So we would want to take that data and convert it into a data frame with a list of lists as x and y. This is pretty simple. We can basically assign this to a variable refract, initialize it as a data frame with get complete refractive as the first argument, and the columns we want to name them the x that we just defined. So that's the x-axis title wavelength, and on the y-axis it's n for refractive index, close to parentheses. So this will give me a data frame for the refractive index. I can look at the start of that data frame, and we'll see that we'll basically have a table that shows the refractive index versus the wavelength. I want to make sure that I have the right index here, so I'm going to set the index of that data frame to that x variable, and I'm going to do this in place. So this will just take wavelength lambda and make that an index of this data frame. All right, so we've got one data frame, and we will also want the extinct data, extinction data. So we'll just do the same piece of code as extinct a data frame that loads the extinction coefficients from the materials database that we loaded, and we'll name the columns X and K. Get complete extinction. So it's the equivalent to the complete refractive. We want the complete extinction coefficients as a wavelength dependent list of lists. And again, we're going to set the index here to wavelength. So we've got two data frames, refract and extinct, that both have the same same x-axis. And for MPContribs, the best solution here is to basically combine that into one data frame, one table, and add that to the contribution. So we'll join these two, call it df. We're joining refract with the k column of extinct. That will give us that data frame. You can see that we have now both columns in there versus the same wavelength axis. And the last piece that we want to do here is assign some titles and labels to it. We could, I could graph this first and just call plot on the data frame. This should give me this interactive plotly graph where I can see the refraction index and extinction coefficients against wavelength. What I want to change here in terms of attributes is what it says on the y-axis and in this legend label and a title. So I would go back into this cell and set df attributes to title, the title attribute, and we'll call it complex refractive index, which is this n plus the imaginary part k for the formula that we did it for. So this would be gold. And we'll also set the labels, which is the value and the variable here. We can overwrite those, and set that value to n comma k, and the variable to real imaginary. I'm going to use that to redo the graph, which should get you here. I'll give you a minute to catch up. Hope you can still see most of the code. And to repeat, we've done two data frames, one with the complete refractive index and the extinction data. We've set the indexes, combined them, and we're basically just looking at an interactive version of it to preview what a graph would look like on MPContribs. For those interested, most of the things that I do here with the attributes and the plotting, that's something that's supported by Pandas DataFrame. So reading the documentation for the Pandas DataFrame would be where you can find more. Okay, so basically we have everything now that we need for for a contribution, we can now take these cells and convert them into a function that gives us a contribution for a specific material in the refractive index data set. I just want to make sure for MPContribs that I also have a name for this data frame that I'll set to n, k lambda. So that's just a name that reflects in a short version what's in that data frame. It'll show up as a name in the table on MPContribs on the MPContribs landing page. Okay, so the last missing link that we need here is to take this code that we have here and kind of merge it all into a function that takes mat as a variable and returns this as a contribution. So what I'm going to do is mark all these cells. Or basically, merge them with the cell above. So you could also have basically selected all these cells and merged them at once. I just did it one by one, give you a chance to catch up. But you should end up with this block of code that does three things. It gets the MP ID, gets some data that we want to add to a contribution, or min or max, and it gets the data frame and sets some attributes on it. So all this we want to now basically pack into a function. Let's call it getContrib based on with an argument of mat, and we'll highlight all this and indent it. So I hit tab, and then it needs to return a contribution. So we'll do what we indicated before. We'll assign this contribution to a project. The identifier is going to be the MP ID. And then we have some data that we want to put in there, namely our number n is going to be n, k is going to be k. So these are just naked numbers, dimensionless. Then we have the ranges, and I'm going to use like range.min to indicate that I want this nested. I could also actually use a nested dictionary, but it's easier to type. So range.min is going to be our rmin value with its unit, namely nanometers. The same for the midpoint that we calculated, where we have the refractive index. So it's going to be mid. So here again, you can see that you're free to give float numbers like n and k that are dimensionless, but you can also include units with it that are going to be checked if they're real units and submit it that way. internally, and through the API, you'll still be able to query the actual R-min value, as we'll see later. The other two that I want to put in here are the points that we get from the material. Those are the points of wavelength on the x-axis, and the page, which has some source information where this info came from, and that would be page info page. So you can see that I'm basically just compiling a dictionary of high-level information that I like to have in the data here, that I like to be shown on the materials project detail page, that I like to be sortable and queryable, and that's important for somebody who would just discover my data set. There might be more in my original data set that I would want to add, but maybe some of it I would put in attachments or actually link separately. I could also add a URL here that links to my own page where I have more data or more information about my data set for this particular contribution. And the last component that we want to add are tables, which is just a list of data frames. So we'll take out data frame that we've defined and put that into tables. So all in all, you should end up with this get contribution function that takes your material and converts it into something that a dictionary that MPContribs would understand. This is something, and that's why I went through the entire exercise. This is something that, and a thought process that you would have to do for your data, and think about what goes where, what do I want, how would I organize it. I've covered the hierarchical data, simple key value pairs basically, and data tables. And you could, just like I'm attaching tables here, you could also add structures and attachments. So I'm going to execute this. So I have this function available, and I'm going to just test it again. Get contrib on the material. Made a mistake. Page info doesn't have an underscore. And what you should end up with is something like this. So again, the project is our project that we assigned this to. We've got an identifier, the data that we want to put in, refractive index, extinction coefficient, ranges, how many points, and where it came from, in this case, Johnson. And then the table that we've created that plots N and K versus the wavelength. That's a pretty good representation of what contributions generally look like. I think you can map that to your own data mentally. I would assign this to a variable contrib so I can use it later. Again, the goal here is in this exercise to just create one contribution and try to upload it and see what happens. Okay, so we've got one. So far so good. And what we want to do now is talk to our project a little and update a few things. I could go and check here, see how that looks like. So this is probably what you should see too, hopefully. If you've asked for a project, you can see that mine is not public. So you wouldn't see mine. I don't see yours yet because I'm also not in my admin account. I could log into my admin account and then this table would hopefully be longer. But for now, you can see that there's nothing in there. I could click on my project, and I would basically see the information that I added into the project earlier. So just again, how did I get there? Basically going to workshop-contribs.materialsproject.org. It'll show me an overview table, and it should show your own project that you've added. And it basically also repeats what we've just done. Basically, how can I create a contribution dictionary and then submit this code? Submit this data in case there wasn't anything in it yet, but we've basically done the legwork already. We have a dictionary that we created. So what we'll do next is to just basically give this to the client. Before we do that, I want to look at the project data that I have in here, maybe the title and the authors, and maybe I want to add another reference. I want to add some description of the data that I'm going to add. So let's start updating some of the project level information in this project. For that, I need the client. So we've imported the MPContribs client above. There's two arguments that it needs. One is the host. So this is the specific MPContribs site that I want to connect to. For us, this is workshop-contribs-api.materialsproject.org. You can, as I said earlier, on MPContribs.org, you can see the other project at the other landing pages and the other projects that you could use, or the other deployments you could use here. This could be contribs.materialsproject.org or light sources or machine learning. For us, we'll stick with this workshop, and we're also going to set the API key. So if everything went well, I should be able to get my project and look at it. So there's a convenience function that just says get project, and we've set the name. So if I did that, I could get that information that's in the project and that we've submitted as part of a dictionary here. And I can see that it's approved. So this is a good sign that this worked. I can see I'm the owner and what the titles and the references were. And there's some things that we want to update here. Namely, one is unique identifiers. What that means is for an entire project, the identifiers, in our case, the MP IDs that we set based on the gold formula, are by default assumed unique. So if you want to do like we'll do, submit multiple contributions to the same MP ID, we'll have to change this flag, which will also disable a duplicate check. So it really depends on the organization of your data, whether you'd want to combine some things into the same contribution. So you could leave this to true and then basically have the inherent MPContribs duplicate check that tells you whether an MP ID is already uploaded in your project or not. But there's other ways around it. So this is more an organizational problem in the data. We'll update it to false, and we'll also add a reference to it and some other information. So let's define a update dictionary that we can submit. Namely, the first one is unique underscore identifiers to false. We will also add, well, let's do this first and try to actually update a project and that flag. So we'll do client.projects. Projects is the resource that we are going to send this update to, and it has a function update entry, and we could look at the help here too. That tells me like update a project. I would have to give it the project name as the primary key, and then a dictionary what my update is. So we'll do that. We'll set PK to name and project to update. And then ask for the result at the end. So what this should do is update the entry in MPContribs, update unique identifiers to false, and if it does, it returns what it updated. So indeed, in this case, we updated unique identifiers to false. And the other thing that I want to do here, I'm going to skip the references update, but I want to definitely add some other data, which is basically a free-form dictionary, again, where the use most of the time is as a legend to your columns. So basically, we just explain what our root level keys in our data dictionary that we created are. Namely, we have an N in there. That is the real part of the complex refractive index. And you don't, I'm going to type this out, but you can write other things here. This is just to explain what those values are. We've got the K in there, which is the imaginary part. We've got the range in there, which is the wavelength range. So this is basically just a good practice example. Like, again, this is free form, so you could skip this. It's not absolutely necessary. But if you want to have your columns explained and shown as a tooltip on MP in the MP detail page, this is something you would want to add and explain your columns. It also allows you to use a much simpler keys and maybe even symbols for your column headers and column names that you can explain here. So these are the number of wavelength points. And the page reference to data source or publication. So if I hit Shift Enter again, it's just going to update that other dictionary. And if we go back to our project, what happened, and I reload this, is that we now have another key here that has this explanation. So this is basically an example for how you could update any data that's up here, including the references and the title or the authors and so on the project level. And one thing we can also do now is basically on the main side, we added the word complex in one of the other descriptions, right? So if I search for this, it would actually find my project. So one other advantage of describing your column keys in your in the other dictionary and the project information is that those texts are searchable and people can find your data set a little easier that way. So it doesn't have to all be in the title or in the description. There's some more information in the description of the columns. All right. Okay, so we're ready to put data up. We want to tell MPContribs what our columns are. So we're going to use init columns, which is a way to just set units for the columns that we've just described and that are in our data. So for our project, we'll give it a dictionary that has the columns in the data as a key, and then the unit as a value. In terms of unit, an empty string is dimensionless. So this is dimensionless number. We said that the refractive index is really only an index. Same for K. Our range, our minimum in the range is in nanometer. So is the midpoint at the maximum of that range, all in nanometers. And the number of points is just an integer, so it doesn't have a unit. And the page, that is the source information, is text, so we'll set this to none. So this is basically also part of a good practice in terms of I want to first, before I upload data, I want to tell MPContribs what my columns are, make sure they're in the right order, because what I give here is basically the order of columns that I want. I could submit the dictionary in any other order I want to, but this is the initialization of what I want. And if I don't do the init columns, it will still work, but it would just figure out the order of columns and the units somewhat automatically from the first contribution that you upload. So if I execute this, I would get back again what it updated. It set the columns key, and I could go to MPContribs now and reload that page in my project, and it should show that I've added these columns, right? So without having any data on there yet, as you see, the table is not showing up, but you can see that our columns are on there. And then we have two last things to do, two cells. One is we want to submit it, and the other one we want to make it public. So let's basically, all we have to do now is give this contribution to client.submit contributions, which takes a list with our contribution that we generated above. And we also want to, because we're all submitting kind of the same data with the same tables, we're going to set ignored dupes to true, which basically means that I'm not going to alert or be concerned about duplicates of tables in my contribution. Internally, MPContribs will only save them once and link them, even if they're duplicated. But it's not a problem that my contributions have duplicates in them. So if I hit enter here, it's going to check the existing ones. It's going to prepare the contribution and submit them. So this took no time at all. I can go back to MPContribs, reload it, and I should see my data. So like this is the one that we uploaded, and you can see the points, we can see the page, we can see the table here. That's all the things that we set, the wavelength. I could go and filter it, but I could also look at the detail page for it. The detail page showed before has all the data in it that as we submitted it, it generated a graph that we did with the complex refractive index and the labels. So this looks all good. It is still private. So if I went back to our overview page, this project is still private. I could go now and take our function that we've defined and submit multiple contributions. I could loop over materials. I would leave that as an exercise. The last thing I want to do is make this public, which is make public our project. And I would execute this, and if I reload, I'll see that this is public. And I can see people there. Oh, this is awesome. So some people followed along. You should all see each other's project now because they're public, and I can go and look for things. So this should give me only this project. Can serve around and look at what happened. And looks like people were really able to follow along. That's great. And yeah, that's actually, we're perfectly in time. What I would say here is you could, in the 20 minutes of break that we have, or as an exercise going forward, you could basically take the notebook that we just established, could go back and basically run this get contrib over all the like all the materials that are in this materials list, right? So you would basically loop over this part of the code, and then in the end create a list of contributions and give it to submit contributions, and it will just add them. There's a notebook in the workshop lesson. It's called contribute.ipynp. I can open that. It has all the code, and it also has the code for like preparing and uploading everything, deleting one, and then it has some extra information of how to actually query your data set. We won't get to that today, but this last part is basically why we've gone through this exercise. Now that data is queryable with operators like larger than and less than, you can sort it, you can map out different fields. And I've left you here with a list of things that you could go and explore a little more. Thank you very much. That was the lesson on MPContribs.